Welcome to the deep dive. Today, we're zeroing in on a really technical role, but one that kind of underpins so much the calibration technician.
hmm
We want to unpack what this job really involves, the skills needed, and I guess why it's so vital across, well, so many industries.
Exactly. And we've actually used a set of typical interview questions for calibration techs
Hmm.
as our source material here. So
Oh,
that gives us a really practical, sort of real-world angle on what the job demands. Think of this as your, let's say, quick guide to the essentials of calibration, why it matters, without getting too bogged down in the super technical jargon.
okay, perfect. Let's jump right in then. Calibration. The word itself sounds, well, precise. What is it fundamentally?
Well, at its core, it's a comparison process. Simple as that, really.
A comparison.
Yeah, you take a device that measures something, could be temperature, pressure, or electrical current, even physical size, and you compare its reading to a known standard.
A standard, like something you know is accurate.
Exactly.
Yeah.
A reference point that's highly accurate, often traceable back to national or international standards.
Yeah.
And if the device you're testing, the unit under test, isn't measuring within certain acceptable limits,
The tolerances.
right, the specified tolerances set by the manufacturer, usually,
Hmm.
then you make adjustments. You tweak it to bring it back into that acceptable range.
So you're basically making sure the measuring tools themselves are measuring correctly, like quality control for the instruments.
That's a great way to think about it, yeah.
Yeah.
It's all about ensuring trust and reliability in the measurements.
Right.
I mean, imagine if a thermometer in say, a pharmaceutical lab was off.
Oh, wow.
The
Yeah.
consequences could be huge, right?
Yeah.
Entire batches of medicine are potentially ruined. Calibration is that safeguard,
Hmm.
and it often needs specialized equipment and really specific, detailed procedures.
Okay, that definitely highlights the importance. So what kind of equipment are we talking about here? It sounds like it could be quite varied.
Oh, it really is. Looking at these interview questions, the range is, well, pretty broad. It really shows how diverse the field is.
Like what?
Hmm. Okay, so you've got electronic test equipment stuff engineers use all the time, like oscilloscopes, for looking at electrical signals,
Hmm.
and multimeters for measuring voltage, current, resistance. If those aren't right, engineers might base designs on bad data. That could lead to products failing down the line.
Okay, makes sense.
Then there's dimensional measuring tools used in manufacturing, things like calipers, micrometers, gauges, crucial for making parts that fit together correctly.
Right, precision manufacturing.
Exactly. And then, of course, temperature and pressure gauges. Think about power plants, food processing, aerospace.
Mm.
They're everywhere, and they have to be accurate.
It's a surprisingly wide scope. So, okay, when you're actually doing a calibration, how do you make sure, like, guarantee it's accurate? It can't just be a quick check, can it?
Oh, definitely not. Ensuring accuracy is it's the whole point. The interview answers really stress a few key things here. First, sticking rigidly to established procedures. These are often documented step by step. That means consistency, less chance for human error.
Right, follow the manual.
Pretty much. Then, it usually involves taking multiple readings, maybe running different tests, just to verify everything. You don't just measure once.
Okay, redundancy.
Yeah, and comparing everything rigorously against those known accurate standards we mentioned. And there's this idea of traceability, too, which is fascinating.
Traceability.
Yeah, it means the standards you're using are themselves calibrated against even more accurate standards and those against higher ones, all the way back, ideally, to internationally recognized primary standards, like the standard meter or kilogram.
Wow, so it's like a whole chain of accuracy?
Exactly. It creates this consistent system of measurement globally.
Yeah.
You can trust a measurement made in one lab because it's linked back to the same ultimate reference as a measurement in another lab, potentially thousands of miles away.
That's pretty fundamental. What about the gear you use for the calibration? Does that need checking too?
Oh, absolutely critical. The calibration equipment itself has to be maintained meticulously.
Right, otherwise garbage in, garbage out.
Precisely. If your standard isn't accurate, none of the calibrations you perform with it will be reliable. So regular checks, maintenance, and yes, even calibrating the calibration equipment itself. It's all part of the job.
Okay, that paints a clear picture of the standard process, but what about tricky situations? One interview question mentioned challenging calibrations. What makes one calibration harder than another?
Ah, yeah. That's where the real skill and problem solving comes in. The example given was a high precision scale, maybe in a research lab.
Okay, like measuring tiny amounts.
Exactly. The challenge there is the incredibly tight margin of error. The tolerance is minuscule. Even the tiniest deviation could, throw off research results maybe invalidate an experiment.
High stakes then.
Very high stakes.
Yeah.
So in those cases, you often need even more specialized gear, maybe laser interferometers or something really high-tech, and the procedures become incredibly detailed. Well, you have to account for environmental factors much more carefully.
Yeah.
Tiny changes in temperature, air currents from the ventilation, even vibrations from people walking nearby.
Wow.
All of that can affect a super sensitive instrument. So it requires extreme attention to detail, a deep understanding of that specific instrument, and knowing all the potential things that could introduce errors.
Sounds like detective work almost.
In a way, yeah, you're hunting down sources of error.
Okay. Now, this field obviously relies heavily on technology, and tech changes constantly. How does a calibration tech keep up? How do they stay current?
Yeah, continuous learning is just, well, it's essential. You can't stand still. The interview answers point to a few key ways.
Like training courses.
Definitely. Attending formal training, workshops, seminars, that's crucial for learning new techniques, getting updates on industry standards, maybe getting hands-on time with new equipment.
Makes sense. Stay sharp through education. What else?
Keeping up with industry publications is also really important.
Mm-hmm.
Journals, technical papers, even online forums.
Mm-hmm.
That's where you often find out about new methods, changes to standards, breakthroughs in measurement technology. Staying plugged into that professional community is key.
So it's a mix of formal learning and just staying engaged with the field day to day.
Exactly. You have to be proactive about it.
Now, another thing mentioned quite a bit in the questions was documentation. Paperwork, basically. Why is that so critical in calibration? Seems like the practical adjustment is the main thing.
But the documentation is absolutely fundamental. It's not just paperwork. It's the proof.
Proof of what?
Proof that the calibration was done, that it was done correctly, what the results were, and that the instrument is now performing as it should. Detailed records are essential for, well, accountability, for quality control systems, sometimes for legal or regulatory reasons, too.
Okay, so what goes into these records?
You need specifics.
Right.
Details about the equipment, calibrated serial numbers, model numbers, the measurements taken before any adjustments so you know the as-found condition.
Right.
Then the measurements after adjustment, the as-left condition. Which standards were used for the comparison, the environmental conditions if relevant, the date, who performed it, any notes or observations too.
It sounds like building a really clear audit trail is the goal.
That's exactly it. And good documentation has to be accurate, obviously, but also complete and legible. Someone else needs to be able to look at that record months or years later and understand exactly what happened.
And why is that long-term view so important?
Well, imagine an instrument starts giving weird readings later on. Those detailed records let you trace its history. Was there an issue during the last calibration? Is there a pattern of drift? It helps with troubleshooting, prevents future problems, and ultimately saves time and money by providing that historical context. It's proof of compliance and performance history.
Okay, right. So for you, the listener, maybe you're prepping for a meeting where technical specs might come up, or perhaps you're just curious about these hidden technical roles. Hopefully you're getting a sense now that being a calibration technician is, well, it's much more than just twisting a few knobs.
Absolutely. It's a really skilled job. It demands rigorous processes, incredibly precise measurements, and this unwavering focus on accuracy. And that accuracy ripples outwards, impacting so many things.
Yeah, I think maybe we've all had a few aha moments here, just realizing how critical this calibration process is. Ensuring measurements are reliable across just about every industry you can think of, manufacturing, healthcare, science, tech. It's everywhere.
It really is. And hopefully we've managed to explore that without, drowning you in overly complex terms.
Right. So just to wrap up the key points, calibration at its heart is about comparing measuring instruments to known standards to ensure accuracy and adjusting them if needed. It's this multifaceted field needing specific skills, real attention to detail, and definitely a commitment to ongoing learning.
Couldn't have said it better.
Yeah.
Which leads us to maybe a final thought for you to ponder.
Okay.
Given how widespread calibrated instruments are, I mean, think about your phone, your car, medical scanners, the systems controlling air traffic. They all rely on calibrated sensors and components.
Yeah, you barely even think about it.
Exactly. So what are the potential consequences, maybe the ones we don't immediately see, when this crucial process, this calibration, isn't done correctly? What are those unseen ripple effects out there in the world?
That's actually a really interesting question. Makes you think about how much relies on this often invisible work.
It really does. It underscores just how foundational this technical field is.